Welcome to the Async Coding Interview series by Paul Fruitful. In this season, we'll be focusing on data structures. Grab your popcorn and stay tuned. Welcome to another episode of the Async Coding Interview series. In this episode, we'll be looking at another special data structure named linked list. I know as is a very popular term in the computer world, so you might just get to learn more of what the linked list data structure is. So stay tuned and grab. Okay, first, before we start exploring deeper into what a linked list actually is, first we'll start with the definition. And before I start defining it, I just want to give you a sneak peek at what this data structure is going to bring. I wouldn't be able to deal with this data structure in just one episode, so there'll be about 3 episodes on this particular data structure explaining different concepts and types of linked lists. So it's going to be a very interesting one to look at. So let's look at the definition of a linked list. A linked list is a linear data structure similar to an array with each of its individual nodes having a pointer to the next one. So whenever you think of a linked list, just know it's just like an array with each of its nodes having a pointer to each other. And you can also look at it as a collection with relationships. And to visualize it in our physical world, a chain is a perfect example of what a linked list is. Each of the interlocks of a chain are just pointed to each other. Each of them have a relationship, and each of them are holding each other together to make up the entire chain. That's exactly what a linked list is. So next up, we'll be looking at the types of linked lists. We'll be looking at the types of linked lists, starting from the singly linked list. A singly linked list is a linked list in which each node of this linked list has one pointer, which is the next pointer. You can see in this picture, the head node points to 1 as its next node using this arrow, and 1 points to 2 as its next node, and 2 points to 3 as its next node, and 3 points to nothing, which is null, because null is the base of every singly linked list data structure. So the next one we have is the doubly linked list data structure, and as its name suggests, instead of having one pointer, the doubly linked list, each node has 2 pointers, which is the previous and the next. So unlike this place, 3 will be pointing to 2 as its previous node, and 2 will be pointing to 3 as its next node, and the same thing goes on throughout the list. And the next type of linked list we have is the circular linked list. And I left this picture here so that you can get my explanation visually. So in the circular linked list, there is no null node, and that's because the head will point to 1, 1 will point to 2, and 2 will point to 3, and 3 will point back to the head. And example of one of the systems that implement this feature is your music player. Yes, that's why once the song play to the last song, it goes back to the first song. So that music player implements the circular linked list. So unlike the singly linked list, in which the last node points to null, the last node of the circular linked list points back to the head. The next one we have is the doubly circular linked list, and you can just say it's a mixture of variation between the doubly linked list and the circular linked list. So instead of it having one pointer, it will be having 2 pointers, which is one will be pointing to head, which is its previous. Head will be pointing to 3 as its previous. 2 will be pointing to 1 as its previous, and 1 will be pointing to 2 as its next. 2 will be pointing to 3 as its next, and 3 will be pointing to 2 as its previous. So that's as easy as it gets. So next up, I'll be showing people a visual representation of all of them. And also keep in your mind that once you hear about a circular linked list and you try to visualize it in the real world, just think about a chain that is tied. Yes, a chain like a necklace that you wear, something like that. It's just like a physical representation of a circular linked list. It's unending, it doesn't break. So next up, we'll be looking at the graphic visualization of each and every one of these linked lists. Okay, here it is, the visual representation of each and every one of the types of linked list. So starting with a singly linked list, you can see there's a next pointer to each node, and the last one points to null. And this is for the doubly linked list. The first node, which is the head node, its previous pointer points to null because it's waiting for a new node to be added, so it can, that its previous pointer can point to that new node. So, and also the last node in the doubly linked list points to null, obviously. So next up we have the circular linked list. You can see the circular linked list, there is no null in it. It just like repeats itself like an infinite loop, something like that. It repeats itself, there is no null. This is the doubly circular linked list, and in this one there is two pointers, the next, the previous, the next, the previous, and that same pattern. The previous of the head node doesn't point to null. If instead it points back to the last node, and the last node is next points back to the first node. So you see, one similar feature of the both circular linked list is that there is no null in them. So next up we'll be looking at the applications of linked lists in the real world. Okay, so the applications of linked lists. Obviously, while I was explaining the previous concepts, I was talking about the music player. So now we are going to see some other applications of linked lists in the real world. First of all, we have the previous and next feature in browsers. Yes, that feature that comes up when you're trying to go back to the previous page you were in, and when you go to the previous page, then you try to go back to the next page, something like that. And that feature is brought to you by the doubly linked list, I guess. Yes, it's brought to you by the doubly linked list. The next feature we have, the next application of linked list is they are used to implement other data structures such as hash maps. Yes, they are used in hash maps to solve collisions. We have not yet gotten to the data structure hash map, but we'll soon get there, and it's a very interesting one, I promise you. Next one, they are used in music players. Yes, I've already talked about this a lot. So the next one and the last one is that they are used for the undo and the redo feature. You find this mostly in some softwares like word editing softwares and also content management systems. That undo and redo feature is powered by linked list. And also there are many other implementations of linked list and application of linked list that we use in our day-to-day world, but we don't just get to realize them. There are many more. If I start listing them, I don't think this video is going to end. So I'll see you in the next one, and also I'll be leaving helpful links in my comment section and in my descriptions for you to read more. And in the next video, we are going to be learning about the singly linked list on its own and its implementation. That means we are going to be coding. Yes. Thank you for watching the video. I'll be leaving links to helpful resources to get you grounded in these concepts. I would be releasing a video every Friday, so click the subscribe button and stay tuned. Peace.